VLSos, this is a video lesson on converting a rational function into a form where it's more easy to see the transformations on the parent function 1 over x. In other words, for example, we could be given an equation which is a rational function 3x minus 4 all divided by x minus 2, and we might want to algebraically manipulate this into a form where we can see what the transformations are. In this case, A represents a dilation, H is the horizontal slide, and K would be a vertical slide. How do we change this algebraically? We're working with 3x minus 4 over x minus 2. It takes a little foresight, a little creativity, and it always involves wanting to manipulate the numerator so that a portion of it matches the denominator. In this case, I want to manipulate 3x minus 4 and get an x minus 2 factor out of it. How can that be done? Well, the x term is 3x in the numerator, so I'm going to have to factor out the 3 in order to change it into just a 1x. But when I factor out the 3, I have to anticipate that I'm going to produce a negative 2 as well. So here's one guess at doing that. I have the 3x, and I know that I want to factor out the 3. I'm going to get a negative 2 if I have a negative 6 term. So how do I change the negative 4 into a negative 6 and preserve equality? I need to include an addition of 2 in the numerator. Now I can simplify this back to what I started. I'm preserving equality. And I still have x minus 2 in the denominator. Why would I do that? Because in the next step, I'm going to factor a 3 out of these two terms. If I bring a 3 out of 3x, I get x. If I bring a 3 out of negative 6, I leave negative 2. But those are the two terms that I factored the 3 out of. The plus 2 is going to be independent. It's still there in the numerator. And I'm still dividing by x minus 2. Now I have a factor in the numerator that matches the denominator. That was the project. And I'm going to isolate that piece of it. So I have a 3x minus 2 all over x minus 2. Factors that in the next step are going to cancel out. I still have to represent this 2. It's going to have its own denominator of x minus 2. So I didn't eliminate the x minus 2 in the denominator. But what I did was that I produced a term where with the x minus 2 in the denominator that did not have x in the numerator. And we'll see what it gets us. In this case, after factoring and canceling, I'm going to list the term that contains x first, and this reduces to 3. And we can see that if we reintroduce y, that we now have an equation of the form that we were looking for. Why is this helpful? Because the parent function is 1 over x, and now all of the other numbers can be thought of as parameters which transform the 1 over x parent function. In this case, subtracting 2 is going to move the graph to the right by 2. The addition of 3, which is affecting the y, is going to move the graph up. And the 2, which is affecting, could be thought of as affecting y, by dividing y by 2, is going to be a vertical stretch, factor 2. I would be ready to graph by hand, no need for technology.